What is NAT? This session we will talk about NAT, or Network Address Translation. NAT is a service that is used in routers, and its purpose is to translate an IP address to another IP address. The reason for having the NAT service is to help preserve the limited amount of IPv4 addresses. To prevent a shortage of IPv4 address, engineers developed private IP address and network address translation. In 1994, NAT was described as a short-term solution. We have two main types of IP addresses, public and private. Public IP addresses are publicly registered on the internet. If you type in a web browser "what is my IP address," it will show you your public address. In our case, it's 1.1.1.1. So, what is a private IP address? Private IP addresses are not publicly registered. So, you cannot directly access the internet with a private IP. Private IP addresses are only used internally, such as inside a home or business network. In our case, the home network has multiple devices such as Alice laptop, TV, printer, Amazon Alexa, PlayStation, and many more. Almost all home devices need internet access. So, how do they communicate if private addresses are not routable across the internet? Then the solution is NAT. Let's start with the simplest one, static NAT. This type of NAT is designed to allow one-to-one mapping between local and global address. The local address is the private IP address for the laptop, which is 192.168.0.5. The global address is the address of the router, in our case, 1.1.1.1. Alice wants to go to her favorite web page with the IP address 2.2.2.2. So, her request is leaving laptop with a source address 192.168.05 and destination 2.2.2.2. The laptop knows that the request must go to the router. Routers do static NAT, which means swapping the laptop's private IP address to its public IP address 1.1.1.1, and the destination will remain the same. When the web server responds to Alice's request, the data packet will have the destination router's public address. When it receives packets from the web server, the router instantly does NAT, swaps public IP destination address 1.1.1.1 to private laptop IP address 192.168.0.5, and forwards the packet to the laptop. Then Alice happily can see her favorite web page. Alice also wants to watch Netflix on TV, but can you see the problem? The laptop reserved a 1.1.1.1 public address, so how does the router solve the problem? This time, dynamic NAT comes in. This type of NAT gives you the ability to map a range of unregistered IP address to a registered IP address from out of a pool of registered IP addresses. Fortunately, the router has one extra public IP address, and it's 1.1.1.2. When Netflix requests reach the router instantly performs NAT and swaps the source address 192.168.0.7 to 1.1.1.2. The return way router will perform the reverse operation, swapping public address 1.1.1.2 to 192.168.0.7. Does Alice's router have more public addresses for the PlayStation and other devices? Probably not. A router usually has just one IP address. To solve the problem, the next type of NAT takes place. Overloading NAT, also called PAT or port address translation. This type of NAT is a form of dynamic NAT that maps multiple unregistered IP addresses to a single registered IP address. Many to one, by using different ports. Alice wants to go to her favorite web page again with the IP address 2.2.2.2. So, her request is leaving laptop with a source address 192.168.05 source port 65001 and destination 2.2.2.2 port 443. The laptop knows that the request must go to the router. Routers do PAT, which means swapping the laptop's private IP address to its public IP address 1.1.1.1. The destination IP address will remain the same, and ports will remain the same too. When the web server responds to Alice's request, the data packet will contain the destination router's public address and the web server's source address. When it receives packets from the web server, the router instantly does PAT, swaps public IP destination address 1.1.1.1 to private laptop IP address 192.168.0.5, and forwards the packet to the laptop. Alice happily can see her favorite web page again. How about TV? Alice wants to browse the web page and see Netflix at the same time. Is it a problem with Pat? Not at all. When Netflix requests reach the router instantly performs PAT and swaps the source address 192.168.0.7 to the same IP address 1.1.1.1, but a different source port, 65002. The return way router will perform the reverse operation, swapping public address 1.1.1.1 to 192.168.0.7. That's a lot, right? Did engineers solve the problem NAT as a short-term solution? Fortunately, yes, they develop IPv6, and no NAT is needed. There you go, and keep in mind how essential NAT is. If you have any questions, drop them below, and as always, thank you so much for watching, and don't forget to like, subscribe, and hit the notification bell for more insights.